All right, good evening, everybody. So today we're going to be talking about square roots, and we'll do some manipulation of square roots and take a look at them. We'll use them quite a bit this chapter. All right, so first of all, talking about square roots. So square roots is signified by this symbol, and it is used, we're trying to find a number multiplied by itself it equals the inside number. And we'll see some examples very soon. All right. Okay. Perfect square are numbers that don't have non-repeating decimals or terminating. Non-repeating or terminating decimals. Okay. Radical sign. Radical sign is that symbol. When we do it in terms of order of operations, it's the same as exponents. It also can show us some groupings. So it's done very early in order of operations. It's exponents and grouping. And radicand is the number inside the radical sign. Okay? So the number we put on the inside of the radical sign is called the radicand. Okay, there's our vocab review. Now let's take a look at the next slide. So positive square roots. Positive square roots, an example of that would be something that looks like this. Whoops. Try and write that a little neater. And so positive square root would be square root of 25 is 5. Square root of 144 equals 12. So no big deal there. Now, a negative square root would be one that looks like this. Square root of 36. The answer to this is going to be a negative number. So the square root of 36 is 6, and then the number on the outside makes it negative 6. So square root of negative 49 would be negative 7. Okay, so you do it the same way, you just add a negative sign at the end. Ones that have both positive and negative would look like this. Plus or minus the square root of 81. And the square root of 81, of course, is 9. So then your answer would be plus or minus. And we come across this quite a bit in algebra. So plus or minus the square root of 64, which would be plus or minus the square root. Oh, no, not the square root. Excuse me. It would be the 8. Sorry. All right, and the last one we're going to talk about here are imaginaries. And imaginaries are when we can't do it. So if you have the square root of negative 25, you cannot take the square root of a negative number. The negative has to be on the outside. Has to be on the outside. If it's on the inside, then what we say is no solution. Doesn't matter what the number is. If they do the square root of negative 4, it's got a negative on the inside of the square root, therefore no solution. And I said imaginary because those end up being imaginary solutions later. Okay, so that's a basic square problem. Now let's take a look at some problems. Okay, so here we go. Once again, square root of 49 is equal to 7. And the reason that works is because 7 times 7 equals 49. So I'm trying to find the number that multiplies to give me the radicand, which is right here. This is the radicand. So that's my answer. That's called a perfect square because it does not continue on, it terminates. Square root of 81, negative square root of 81. Notice where the negative sign is, it's outside, therefore no problem, it's negative 9. Okay? Alright, so the first two are no big deal. Now these next two, we got some work to do, and here's where the order of operations comes into play. We want to treat this just like it is a parenthesis. Okay, so it's a grouping. So I'm going to do this 9 plus 16. So the very first thing I'm going to do is I'm going to say the square root of 9 plus 16 is 25. And if I'm looking at GEMDAS here, you may hear that I'm on hold in the background. Sorry about that. And this is left to right, and this is left to right. So the square root symbol is kind of a mix in between these two. It could be grouping. It also could be exponents. So I'm going to have you guys write it like this, I think. Just put the symbol kind of in between. The square root meaning in between grouping and exponents because it's done in both of those. So now I have the square root of 25, which of course is equal to 5. Alright? And the next one below that, we're going to do that one as well. 12 over 3. Now notice two things I need to point out. That this square root symbol goes all the way past the 16. That's super important. You'll see in the next example what happens if it doesn't. And here, the square root symbol goes all the way down to the 3. Please do not write it like this. This here is a completely different problem. This says the square root of 12 divided by 3. This says 12 divided by 3 and take the square root of it. So make sure that you write it correctly. I will be a stickler on this. If you're writing it like this right here, I'm not going to allow that to be correct. So make sure you explain why this is different than this. I'll be looking for that fifth color tomorrow when I check notes. Why is this different than this one? Okay, so in fact, we don't know how to do this one yet, so that's how different it is. This one we totally can do. Coming back to this one then, I can do my 12 divided by 3, which is 4, and the square root of 4 is 2. So that'd be my answer. All right, take a look at the next one here. Okay, here you see the where the square root symbol is stopping. Here it's saying the square root of 36 plus 3. Okay, so that means take the square root of 36, which is 6, and then add 3 to it. And so I get 9. Again, using GEMDAS. And here we're putting the square root symbol kind of in between. Okay, so I always take the square root of 36. I always take the square root of 36 first, and then I do it on the outside. So just like it's a group. The next one, keeping that idea of grouping. This is a group right here. Okay, that's a group. So I'm going to do the inside of the group first. So I have 4 times, and 4 times, excuse me, I don't want to use a parenthesis though. Let me use this square root symbol. 4 times 25 is 100, when I keep writing 4 times 25. So this is equal to 100 here, and the square root of 100 is 10, so then I have 4 times, and then I change it to parentheses. And that's why I'm saying it's kind of like grouping here, because it's another way of writing a group. So then I have 40 for my final answer. So the answer to this one is 40 right here. What am I doing? 400. How about we do 40? There. Whoop. There we go. Okay. So this one has a lot of stuff going on. I got to make sure I follow order of operations. So the first thing I'm going to do is 6 and then square root. Inside my square root, I have my exponent. So I'm going to write that down, which is 9. How I knew to do the exponent first is because exponent comes before division. So before I divide here, I'm going to do my exponent. I'm always following order of operations. Please make sure you write that down. Now I've just done the exponent, therefore I can now do this. 32 divided by 2 gives me 16. So I now have, notice that, by the way, I want to point this out. Notice the 10 is outside the square root symbol, so the 10 is going to be done last. And then minus 10. So now I have this equal to 16 plus 25, or excuse me, 16 plus 9 is 25, so 25 minus 10. Square root of 25 is 6. I'm going to take it out of the square root symbol. I turn it into a parenthesis, minus 10. 6 times 5 is 30 minus 10, which is 20. So that's my answer right there, 20. Alright, and the last one here, you see I didn't leave myself much room, but I have enough room. I'm going to once again follow order of operations up here. So I'm going to do the square root symbol first, leave all this stuff on the outside until later. So I have 4 times on the square root of 8 minus 10 gives me negative 2 times 3. And what I notice right now is that that negative symbol is on the inside. So that means no solution. I'm done. I can't do anything because the negative is on the inside of the square root symbol. Okay, so that's a lot of different examples of square roots. We will go over quite a bit of them tomorrow, and make sure you do good fifth color blue columns and summaries, please. See you tomorrow.